Let us look inside a heavy military production line and see how industrial precision supports Ukraine's wartime manufacturing capacity. This is not only about artillery systems, it is also about steel, machinery, and inspection. Every shell casing passes through multiple controlled stages, where accuracy and consistency matter at every step. At its core, an artillery shell is a carefully engineered metal projectile. When fired, a controlled ignition system moves it through the barrel under extreme pressure. That is why the outer casing must be strong, carefully balanced, and manufactured to strict military standards. Even small defects can create serious risks. A 155mm artillery round is built around several major sections. The front section holds the fuse assembly, which is handled only under specialized military control. The main body is the largest visible metal component. It is formed as a hollow casing, with exact dimensions and a carefully finished interior. The base section is designed for the firing system. But this factory focuses mainly on the metal casing itself. Now that we know the basics, let us follow the manufacturing process. First, a forklift delivers heavy billets of high-grade steel. Each piece weighs around 65 kilograms. The steel must meet strict requirements for strength, hardness, and structural consistency before it can move deeper into production. This is not ordinary construction steel. It is selected for demanding military use. Special alloy steels are often chosen for their durability and their ability to perform under extreme stress. Once the billet reaches forging temperature, the machine transfers it into a powerful press. The outside begins to take a rounded shape, while the core remains dense and solid. Then it moves to a second forging station nearby, where different tooling reshapes the body from within. The first press gives the steel its outer profile. But this stage begins forming the hollow interior. After that, a robotic arm places the body on a conveyor, where it cools gradually over several hours. In reality, performance depends on far more than shape alone. Every surface matters. First, the casing must match the artillery system's design. The rear section must align cleanly with the pressure and sealing requirements of the barrel. During operation, extreme force acts on the base and outer walls, so the geometry must be carefully controlled to keep movement through the barrel stable and predictable. A copper driving band is fitted around the body, near the rear section of the casing. It works with the barrel's internal rifling, helping the projectile rotate as it travels forward at extremely high speed. That rotation is one reason accuracy depends on precise machining. If one feature is out of tolerance, the entire round may be rejected. Now, let us return to the factory floor. After cooling, the body is reheated for further forming. A robotic arm places it into a machine that applies steady vibration and pressure. The metal rotates while the neck is formed inward. In about a minute, the once open metal body begins to take on a pointed profile. This creates the basic shell casing shape. But forging is only the beginning. Next, the casing is placed into an electric furnace upside down and heated for roughly 2 hours. This heat treatment changes the steel and improves hardness, durability, and structural consistency. Next comes metal integrity testing. The material you see here is lubricant. The dark outer coating is not rust, but an oxidation layer. Technicians position the casing on a workbench. Then a measuring device checks the hardness of the metal surface. This helps confirm whether the heat treatment was successful. The AS-90 self-propelled howitzer is one artillery platform supplied by the UK to Ukraine. Vehicles like this require ammunition. That meets a consistent 155mm standard. Before any field use, all components must pass strict handling and quality checks. Self-propelled artillery is designed for mobility, protection, and rapid repositioning. Towed artillery uses a more traditional setup, but in both cases, manufacturing quality is essential, especially when large batches are produced under pressure. Now we enter the next processing stage. At this point, the entire surface is covered by the oxidation layer. The level of precision here is critical, so technicians load the casing into a machine tool. for continuous milling and surface finishing. Its color, brightness, and surface quality all become much cleaner. Now, the main body of the casing is ready. The next key part is the copper driving band. Whether made from copper or brass, this softer metal plays an important role. A robotic arm lifts the casing and places it into the next station. Once it reaches the correct height, the machine presses the band into position. The next step is inspection. This process is simple but important. A light is inserted into the casing, so the interior surface can be examined closely. If rough areas or impurities are found, the surface must be cleaned and polished. The threaded tool being tightened here is used temporarily to verify the fit. It is removed after the inspection is complete. Next, protective rings are fitted around key areas of the casing before painting. They help guide the finish. With lubricant, the coating can be applied more evenly. Even with a thick protective layer, the final dimensions must remain within tolerance. Below the painting area, a conveyor moves the casings to the next station. 3 workers at 3 stations carry out separate quality checks only after passing final inspection. Can the casings leave the production line? The loading of energetic materials and fuse assemblies is not part of this factory's visible process. That work is handled only by authorized military facilities, under separate safety and security controls.